Hello everyone, my name is Meridith Ebbs. I'm coming to you from Biripi country in Port Macquarie, New South Wales, Australia. I'd like to acknowledge the traditional owners of the land where I work, live, play and learn. I'd like to acknowledge the custodianship of this bushland, the waterways and the coastline, and the ongoing knowledge and sharing that continues to this day. I'd like to acknowledge the elders, past, present, emerging and in the future, and acknowledge their ways that we should be learning from each and every day. Around me there is so much medicine, bush food, and so many more things I could learn from the traditional people. And each fortnight we go outside to actually learn that. My presentation today is about the space wattle and how we worked with the space wattle in a classroom environment. Some of our activities were done here in the bush, looking into our wattle in our local area, and some were done in the playground and others in our classroom. I hope you enjoy my presentation today, and I'm looking forward to connecting with you online in cyberspace. Welcome to this presentation on sustainability in space. This presentation has been inspired by our school's opportunity to participate in the Space Wattle program with Jackie Carpenter and One Giant Leap Australia. The activities were conducted by our Year 3 and 4 class, which are aged between 8 and 10 years old. The Nature School has 76 students and we're in Port Macquarie in New South Wales on the east coast of Australia. Our philosophy is to learn in nature, from nature and about nature. We teach the mainstream syllabus for our state, but we do it in a creative and different way, where a lot of our learning is conducted outside. This is a copy of our application last year to One Giant Leap Australia to win the Space Wattle opportunity.
Action. Seeds returned from outer space now begin the growing race. What'll happen to the wattle? Will they shrivel in the night or grow at rapid speed of light? What'll happen to the wattle? Pollen carries on the breeze. Will the pollen make us sneeze? What'll happen to the wattle? Grow upside down, or will gravity keep them on the ground? What'll happen to the wattle? If summer heat is really dire, will the plant still handle fire? What'll happen to the wattle? Or if we have another flood, will the plants drown in the mud? What'll happen to the wattle? Will the plants grow arms and legs and have alien eyes and alien heads? Dude, that's just weird. What'll happen to the wattle? We think experiments are pretty cool, so please send seeds to the nature school so we can find out what'll happen to the wattle.
So the project I came up with was to create a habitat that uses sustainable energy and minimal waste that would be suitable for use on the moon. These are the curriculum areas that we were to cover. As you can see, there was quite a range of areas, but we did manage to meet them all using the space wattle as our inspiration. We did quite a few science investigations, and the first one was exploring the sun's relationship to the Earth and the moon. The students were quite fascinated to find out that you could tell the time with a stick and a plate. They were amazed that the shadow would move around the plate and that the length of the shadow changed with the time of day. And they wondered, would this be the same on the moon? And would the time still be the same time? We planted the wattle this term. It arrived in August, but due to remote learning, we were unable to plant it until October. So to date, we're still waiting for seedlings. Hopefully we'll get some seedlings and some measurement results before the end of the year. Our third investigation was about light and light levels. The students coded a microbit using the MakeCode software to measure light levels around our school. They then took their microbit with them around the school, pressing button A in each location to find out what the light level was and how it differed between inside and outside and in different spaces around the playground. They discovered that the light levels for learning is most ideal at 250 lux. They found our classroom is a little dark for ideal learning, so it's lucky that we actually spend a lot of time outside. By far the most popular science investigation was the s'mores. We investigated using heat and light for cooking. They used magnifying glasses to melt the marshmallows. Then they placed the biscuit, the marshmallow, and a small chocolate melt into a solar oven. We made these solar ovens in a previous term, but the purpose of this activity was to measure the temperature that inside the oven would get to. Unfortunately, a cloud came over during the activity, and we only got a maximum of 48 degrees Celsius inside the solar cooker, which is about 118 degrees Fahrenheit. I do really believe that if we were to repeat this activity, that we would get in excess of 50 degrees inside. I have had a board up to 55 degrees for a microbit. Given that we're nearly at the end of the year, the students are very hopeful that we would repeat this activity again in December, which will be our summer. The students were quite disappointed when a cloud came over in front of the sun and halted the investigation quite abruptly. But the industrious searching for some paper bark from a local tree, they were able to make 2 small fires on top of the marshmallows, which you can see here, to try to kickstart the melting process. For those of you who are unaware, a paper bark is a local tree in Australia. The bark is like a very thin tissue paper and very flammable. Paper barks grow in swamps and wetlands, and there was actually some in that video that we saw before. However, because they're in swamps, they often don't catch on fire. During our Black Summer fires, a lot of paper barks in our bushland area caught alight, and there are quite a few that have died, and there's still some that are not recovered from the fires. They're not as resilient to fire as the eucalyptus tree. We also discussed the fact that there was no paper barks on the moon, so they were going to have to find another way to get their marshmallows melted. Our maths investigation was around position. It also included some incidental mathematics concepts such as measurement and positional language. Because Bluebots are quite a basic robot, you can see here and here are the Bluebots, I asked them to extend the grid and make a larger map for the Bluebot to travel. This required the students to draw with chalk on the carpet an extra grid of 15 centimetres. This was really good practice for them for their measurement skills. In the second picture, you've got dot and dash, and dot and dash work a little bit differently to Bluebots. They require coding, and their distance is determined by speed. So the students had to find an appropriate speed that they could use where they could estimate the length and distance it would travel. And once again, the students had to then code the pathway for the robot. The purpose of this activity was to compare it to being a lunar vehicle for use on the moon. Our second maths investigation was to do with 3D shapes. So they had to design, using isometric drawings and a 3D splat, the habitat on paper first. You can see, if you look very closely at the picture on the right, there's tunnels joining different parts of the habitats together. There's solar panels, which is the checkered parts with the triangular prisms. And then there's also a cube sitting up near the sun, and that is a terrarium or a greenhouse with water. The students envisaged that the water would contain fish, which would allow people living in these habitats to be pescatarian and not just vegetarian. They had to consider the building design, the fact that there was very low gravity. They had to consider energy sources, hence the solar panels, water source. So we had watched previously videos of how the astronauts obtain their water from their sewer waste. And waste disposal was also a topic of discussion as there is nowhere to put rubbish. So we discussed the fact that the moon habitat would have to have no plastic. One group plans to have bamboo growing in one of the greenhouses so that eventually they would have a source for timber and a more durable material for use on the moon. This maths investigation was to do with 3D shapes and position. The base of the habitat is built on a cardboard box for a TV, and then I've covered the cardboard in a grid paper. Each child was given a 25 by 25 centimetre grid, and in their maths grid books they had to design the layout of their habitat from a bird's eye view. So each child in the class was given one grey square, the grey representing the surface of the moon. You can see if you look closely that there is cylinders joining the different pods together. This one's a really good example because it's white. There's trees, which represents the space wattle. The triangular prisms in the top right corner are the solar panels. The pink rectangular prisms are batteries. The students also had a 2D shape activity where they were given small triangles of different sizes and they had to create pentagons and hexagons. I then joined those together for them to make that one dome. Another maths investigation that we did was to investigate a local species of wattle, Acacia floribunda. The students learnt that the leaves are long and narrow with parallel veins, and each flower is actually made up of multiple small yellow balls that look like pom-poms. The students were required to use a mud map to identify the location of each tree that they found in the bushland. We also did scientific sketches of the flower and leaves, and we found out that there's a small gland at the base of this species which looks like a little hole in the base of the leaf. The students were exceptionally excited to find out there was another robotics lesson. This one goes with an Ozobot. They had to design tracks for lunar vehicles to be able to travel around the habitat. They had pathways with codes, and each code made the robot or the Ozobot do a different activity. They also had to troubleshoot as they realised that the Ozobots don't travel on a coloured background, so we had to have white pathways with black paths. They realised that the paths had to be a consistent thickness, and they also had to have the colours done in a certain order or the codes didn't work. They had another design activity on costumes and how to make the costumes for the Ozobots. We had a variety of characters, and my favourite was the green alien. We also had a space dog, and we had just a standard lunar vehicle which could be used to travel round in. We also watched an episode of The Jetsons prior to this so that we could see what types of things people envisaged about space travel in the 1960s, just prior to the man landing on the moon. We watched a moon landing to see what minimal gravity looks like, and we listened to some of the broadcasts by the astronauts back to Earth. While we were studying 3D shapes and building our habitat, we were also learning about factual texts in English. They were researching energy, fossil fuels and solar energy, and they had to summarise that information for later use. They were learning about hydroponics, and they did reading and comprehension on different types of hydroponics. They had to choose their favourite and the one most suitable for their habitat and summarise their information about that for later use as well. Locally, we have a hydroponic grower called Ricardo's Tomatoes, and he grows strawberries and tomatoes hydroponically. Ideally, we would have visited this site. Unfortunately, remote learning had different plans and COVID restrictions prevented that. The students then had to write a news report on the space habitat. In that report, they had to include information on the sustainable energy that they were planning on using and how they were planning to grow their food. So the paragraphs that they had summarised in previous lessons became part of their scripts. They had to present their information as either a documentary or a podcast. Most chose to do a documentary. And then they had to edit their recording. This required quite a lot of ICT skills, and then we could showcase what we had done to our parents by sending the documentaries home in a Microsoft way. The final English task was an information report, where they had to research fossil fuels in more depth and summarise and write paragraphs using a scaffold, and create an information report for publication. We'd like to thank One Giant Leap for including us in the Space Wattle program. We learned a huge amount. We had an enormous amount of fun learning and making all of our space habitats and learning about space in general. This is a list of the resources that I used and referred to during this presentation. And if you'd like to connect with me, you can meet with me in cyberspace on Twitter, Instagram, and Facebook. You can find me as iMaryNet or Make, Create, Educate. Please connect and reach out. I love meeting with other teachers and hearing what you're doing in your classroom. Thank you to One Giant Leap Australia for allowing me the opportunity to share with you our project.